Yes friends, so I'm continuing with the same explanation. So answer of this is 72.8%. Okay, this is the percentage increase in volume. Okay, the volume of the cone will be increased by 72.8%. How this value is obtained? Now let me explain this whole thing and how this formula is obtained and what is the shortcut formula for this. Now let me explain this whole thing. I want to explain this whole thing. Suppose there is a cuboid. The volume of cuboid is x into y into z if its sides are x by z. So its side is, let me take its side as 100. First let me clean it. Yes friends, so this is okay explanation of this question number 2 I was doing first, and for questions 1 and 2. Question number 1 and 2, what is the explanation? Now let me explain this. If there is a cuboid, let me take, if there is a cuboid of 3 different lengths, LBH, length, breadth and height. If there is a cuboid of 3 different lengths or dimensions, here lengths means LBH, LB into H. This is the volume here. The volume of that cuboid will be this, LB into H, length, breadth and height. 3 different dimensions are there. Okay, and if length means here dimension, 3 different dimensions. 3 different dimensions. And length is increased. Let me take length is increased by X%. Breadth by Y%, let me take, and height, let me take its height, and its height is increased by Z%. Then the shortcut formula to find out what is the volume increase, what is the increment in volume. Then the shortcut formula for finding the percentage increase in its volume is equal to, is given by, this is x plus y plus z. X plus y plus z, these 3 are added up, plus, okay, and plus, this is x by plus yz plus zx divided by 100, plus second case is x into y into z divided by 100 square, 100 whole square. So this is the shortcut formula. Okay, if x, y and z, there are 3 different kinds of increment in 3 different dimensions, then volume increased, increment in its volume will be obtained by this basic formula, x plus y plus z. These are the different increases in 3 different dimensions, and x into y, double multiplication, x by z, zx upon 100 divided by 100 whole square. So this is written as percentage increase. If I write here, this is percentage increase into multiplication by whatever value is obtained after putting these values, these increments in this way, x plus y plus z. Now if these increments are same, similar, just as in these two questions we have obtained 10% and 20%. So, okay, so if it is suppose x% increment, now if the increment is equal, then formula will be what? If the percentage increase, in three dimensions is similar or equal, just as x%, let me take all the dimensions means length, width and height, they are increased by x%, then the formula is obtained by, then volume will be increased by, then increment in volume, let me write, then increment in volume of the cuboid will be equal to how much? Equal to, this is x, so 3x, plus this is x square plus x square plus x square, it will be 3 into x square divided by 100, plus this x into x means x cube upon 100 whole square. This is percentage increase. If there is increment in, in all the three dimensions, equal increment there by x%, suppose. If this percentage increase x, then the formula is this. So this is shortcut formula for this. How this formula is obtained? Now that is the question. Let me talk about how that formula was obtained. Now let me take and let me explain this and how this volume, increment in volume is obtained. Now if I take, if there is a cuboid, let me take, just to explain this, if there is a cuboid, if there is a cuboid, the length, breadth and height and its height all are increased by, let me take, all increased by x%, y% and z%, right? X, y and z% lengths are increased. Now if I find the volume of this, suppose there is now, okay, just for the calculation point of view, for simplification of the calculation, let me take all the three dimensions are length, breadth and height are 100 meters. Okay, if for calculation point of view, just for calculation point of view, let us take all the three dimensions are 100 meters. Let me take 100 meters both. It means the volume will be what? Therefore 100 meters, and therefore volume. Now in this case it will be cuboid, or cube, because all the three dimensions are equal, but let me take, this is a cuboid, so 100 meter. So volume of the cuboid will be 100 into 100 into 100, that means 100 whole cube. This is first equation. And the new volume, let me change this marker. And the new volume, okay, and the new volume is equal to 100 plus x, because percentage increase, into 100 plus y into 100 plus z. All the three dimensions are increased by x, y and z, percentage increase. So the new dimensions are 100 plus x, 100 plus y into 100 plus z. These are the three dimensions. Length is this, breadth is this, z, and the height is this. So if I multiply them, the volume is obtained. Then the new volume will be what? If I multiply them, we will obtain as 100 whole cube, and this is 100 whole square into x plus y plus z. If I multiply them, we will obtain this kind of formula, plus this is 100 into xy plus yz plus zx, okay, plus x, y and z. Okay, so this is whole cube. 100 whole cube will be obtained, plus 100 square into x plus y plus z, plus 100 into x by z plus zx, plus x into y into z. This formula will be obtained. This is new volume. Therefore, the increment in volume will be, therefore, increment in volume, therefore, the volume, increased volume, therefore, increased volume or increment in volume, that we take. What is the increment in volume? Increment in volume is equal to, now this increased volume minus previous volume, this 100 whole cube will be subtracted. So the increment in volume will be 100 whole square into x plus y plus z plus 100 into x by plus yz plus zx plus x by into z. This is the increment in volume. Now what is the percentage increase? Therefore percentage increase will be, if I divide this by 100 by 100, sorry, volume, increment in volume, therefore percentage increase, therefore percentage increase in volume is equal to, what we have to do, this increment in volume, this divided by previous volume, that means this is 100 whole square into x plus y plus z plus 100 into within bracket x by plus yz plus zx plus x by z within bracket, this whole divided by 100 whole cube volume, the previous volume. But percentage increase in volume is obtained like this, into 100, but this is percentage increase. So this means 1 over is cancelled out by this 100 because this is percentage increase. Now I have to put here, this is percentage increase in volume. So then put here percentage increase, and this is into 100 of 100. So this is 1 0 and this 100 cancelled out. So this is only twice power. So this will be obtained, this whole 100 square is 100 square cancelled out. We will obtain only x plus y plus z plus, and this 100, okay, this is x by plus yz plus zx, okay, this is x by plus yz plus zx only upon 100 plus this x by z, x by into z upon 100 square. Okay, so this, all these values are obtained. So this is the percentage increase in the volume. So this is 100 whole square, because this 100 whole square x by z upon 100 square, because this with this percentage of 100 increase, percentage increase in volume. Okay, so this is the percentage increase in volume. Now if I take that these increments are similar, then so or if, let me take, if the percentage increase is equal, so put here x equal to y equal to z. Let me take this is equal to, let this is equal to x. If I put here x, this will be 3x. So percentage increase, therefore percentage increase percentage increase equal to 3x plus, this is x square, this is 3x square plus x cube, 3x square upon 100, and this is x cube upon 100 whole square. So this is percentage increase. This is how we calculate the percentage increase in volume, right? So this is percentage increase in volume. This is how this formula is applicable. Now if I put here percentage increase equal, so this is x. In this case we were having x was 10% in first question. In second question it was 20%. So we put here in place of x as 10%, 10%, 10 in question number 1. In second question we put here 20%. Okay, 20, I mean x in place of value. X we put 20 in second question, and first one 10. All these questions were calculated by this shortcut formula. Okay, or we could just write that, let us assume that previous the radius is r, height is h, and then increased is r plus 10%. Okay, r plus 10 percentage we will put later on, and then find the new volume, then subtract that. From this new volume, subtract the previous volume, the increment in volume will be obtained. Then that increment divided by the previous volume and percentage increase. That is the longer method. So this longer method we have to use this shortcut method. Okay, so this is direct formula, shortcut formula we can apply for finding the increment in volume. Okay, this is question number 1 and 2. This we have just calculated. Question number 1 and 2 can be calculated by applying this shortcut formula. Okay, so this is how question number 1 and 2 we have solved. Let us take now question number 3. Now what is question number 3? Let me now check it. Question number 3 now. Now question number 3 is of what kind? Okay, question based on cylinder and cone continued. This is continuation of the previous lecture series. Question number 3 says a cylinder, a hemisphere and a cone stand on the same base and have the same heights. Then the ratio of their volumes and also the ratio of their areas of their curved surface. Find the ratio. Then the ratio of their volumes and also the ratio of the areas of their curved surface area. So we have to find out what is the ratio of their curved surface area and volumes. If the cylinder and cone, for example, if I take this is a hemisphere, okay, and cone is also there. This is the cone here. There is cylinder also. Cylinder is also having the same base. If I take here, same base like this. This is cylinder here. So hemisphere, okay, hemisphere, cone and cylinder having the same base and same height. This is the same height here. Okay, so this is question number 3. What is given to us? We are given here a cylinder, hemisphere. This is hemisphere. Hemisphere and a cone. And a cone are on the same base. Same base and same heights, and with same heights, and also given same heights and with same heights, same bases and with same heights and the same heights. To find here, what we do find here, to find what is the ratio of their volume. First is ratio of their volumes. What is the ratio of their volume? Second point is ratio of the curved surface areas. curved surface areas. What is the ratio of their volumes and ratio of their curved surface areas? That we have to find out. Okay guys, let me find the solution. Now if I take that this is total, let me take diameter is x, height is also then, okay, so this radius will be, what is the radius of this? So radius then will be x by 2. Okay, if I take radius is x by 2, then it's, for the hemisphere the height will also be x by 2. Okay, x by 2 is the height, radius is the height, radius is also the same. For hemisphere the radius is the height. So similar height is for cylinder and cone and everything. If I take axis diameter, x by 2 is the radius. Okay, so let me take, if x by 2 is the radius, so if I take x is the diameter and x is the radius, x by 2 is the radius of the base, then height of the hemisphere, is also equal to x by 2, because they are the same radius, and this will be used, this x by 2 will be used as height for cylinder also, for cone also. This is vertical height here. Okay, so therefore volume of cylinder, let me put directly the ratio, volume of hemisphere is to volume of cone, Okay, so this is, what is volume of cylinder? Pi r square is x by 2 whole square into x by 2, because h is also x by 2, height is also x by 2, is 2. Now volume of hemisphere is half of the volume of sphere, so this is 2 by 3 pi r cube, pi into x by 2 whole cube is to 1.3 volume of cone, pi r square h, this is pi into r square, means x by 2 whole square into x by 2. So we could take, in place of x we could take r only, so this is r by 2 here, or if I take d diameter, then this is d by 2 radius, and this radius will also be, because hemisphere is having same height, okay, and the height of the hemisphere is x by 2, the same equal to radius. Okay, so this is the volume. Let me just find out this 3 cancel out, this 3 LCM, 3 will come here, and x cube upon 8, here x cube upon 8, okay, and only 2 is there, and this x cube upon, here also 8 is there, so x cube upon 8 cancelled out, pi cancelled out. So the ratio here, let me just find out the ratio. Finally the ratio of it will be, so V1 V2, so ratio of volumes, so ratios of volume is equal to, now this is, let me pi cancel out, so this is x cube upon 8, let me put here again, is 2, here it will be 2 by 3 is further taken out, and this is x cube upon 8, and here it is 1 upon 3 volume of this, and into x cube upon 8. Okay, so x cube upon 8 cancel out, so this is 3 LCM, here it will be 3 is to 2 is to 1, is the ratio here, 3 will come here, 3 is to 2 is to 1, this is the ratio of the volumes. Okay, so ratio of the volumes is this. This is the first answer, the ratio of their volumes, question number, this 3 question number 3 we are solving. Now let me find out the volume of their, ratio of their curved surface areas, the ratio of their curved surface areas. Second point, so ratio, second point is ratio of the curved surface areas, curved surface areas. What is the curved surface area? Yeah. So ratio, curved surface area of cylinder is 2 pi r means x upon 2 into h is x upon 2. 2 pi r into height h is 2, and this is curved surface area. That means just half of the area of the cylinder. So this is 2 into pi r square. That means x by 2 whole square, because 4 pi r square is the area of the cylinder, of the sphere, and half of that is hemisphere. So 2 pi r square into pi r. Now pi into r is x by 2 into L is x by 2 whole square plus x by 2 whole square, because r square plus h square, r and h both are of cone x by 2 because this vertical height. So pi cancel out, pi cancel out. So this is nothing but 2 into x square upon 4 is 2. 2 into x square upon 4 here also. Here it will be x by 2, okay, and from inside we will get x square upon 4, x square upon 4, so twice x square upon 4, x square upon 2, it will be x upon root 2, x upon root 2, x square cancel out. This is 1 upon 2 is 2, 1 upon 2, same ratio, 1 upon 2, 1 upon 2, and this is 1 upon 2 root 2, 1 upon 2 root 2. So root 2, LCM is 2 root 2. So here it will be root 2 is 2, root 2, root 2, yeah, is 2, 1. Root 2 is 2, root 2 is 2, 1. This is the final ratio of the curved surface area. This is the answer of question number 3, second answer. Second answer is this much. Okay, hence the formula is this. This is question number 3 here. Now let me talk about question number 4. What is the question number 4? Now question number 4, let me talk about. Question number 4, guys. So this is question number 4. What does it say? Let me just first clean this. Okay. Now question number 4 is of what kind? Now it says that a right circular cone is exactly fitted inside a cube. Okay, inside a cube. A right circular cone is exactly fitted in inside a cube. So let me take the cube. Cube is a figure having equal sides, length, breadth, and height equal. Okay, there is a cone here which is fitted inside this. This is top of this cone, and then this base will touch the middle point of this. Okay, and this middle point joined here, and this middle point is also joined here. This is the cone here. Now what is say? A right circular cone is exactly fitted inside a cube in such a way that the edges of the base of the cone are touching the edges of one of the faces of the cube. So base face is being touched by the base of the cone. Okay, the base of the cone are touching the edges of one of the faces of the cube.